Let's solve this initial value problem. So here we have the equation y double prime plus 10y prime plus 24y equals 144 t squared. And we are given this initial conditions, that is y of 0 equals 19 over 12 and y prime of 0 equals negative 5. So I'm going to solve this initial value problem by the method of undetermined coefficients. So basically this involves four steps. The first step, we have to find the complementary function, or otherwise it's also called as the homogeneous solution. And then we have to find the particular solution. And in the step 3, we have to find the general solution, which is the sum of the complementary function and the particular solution. And finally, we have to apply the initial value conditions to find the final solution. So let's start off with step 1. That is, here we have to find the complementary function yc. And we find this by setting up the equation, that is the left side equals 0. So I'm going to set it up as y double prime plus 10y prime plus 24y, and this equals 0. So now we write down this auxiliary equation by substituting y as 1 and y prime as r and y double prime as r squared. So y double prime is replaced as r squared plus 10 times of y prime is replaced as r plus y is replaced as 1. So it is 24. This equals 0. We now have this quadratic equation in r, that is this is r squared. Let me make it a little bit clearly. So we have r squared plus 10r plus 24 equals 0. Now we can write down in factor form. So I'm going to write down this as r plus 6 times of r plus 4, and this equals 0. Because we have a product 24 and a sum 10. So the two numbers are 6 and 4. The product of these two numbers are 24, and the sum of these two numbers is 10. So this factorization is correct. Now we can write down the complementary function. Before that, we will find the r, the values of r. So if we let r plus 6 equals 0, we get one of the solution for r, that is r1 equals negative 6. And if we let r plus 4 equals 0, we get the other value of r, that is r2, and this equals negative 4. So we found two values for the complementary function. So we are going to write down the complementary function now, or otherwise it's also called as a homogeneous solution. So we write down yc, and this equals the general form is we have to put a constant, that is I put this constant e raised to the power of r1t plus I put another constant c2 and then e raised to the power of r2t. Now let's substitute the values of r1 and r2 into this complementary function. So we get y sub c, and this equals c1 e raised to the power of r1 is negative 60, that is r1 is negative 6 times t is negative 60 plus c2 e raised to the power of r2 is negative 4, and negative 4 times t is negative 40. So we found the complementary function yc equals c1 e raised to the power of negative 60 plus c2 e raised to the power of negative 40. And this completes step 1. Now let's do step 2. So in step 2, we have to find the particular solution, which is represented as yp. And for that, we have to look at the right side expression and determine the generic form of the right side expression. So this looks like a quadratic expression, that is 144 t squared is basically a quadratic. So we can write down the the particular solution in the form of quadratic expression, that is yp. We write down this as at squared plus bt plus c. So this is the form of the particular solution. And now we can substitute into this equation. So for that, we need to find the first and second derivatives. So let's find the first derivative of yp. So I write down yp prime, and this equals, we have to find the derivative of each terms. The derivative of at square, that is, we have to find the derivative of at square. The a is a constant, we keep that as it is, and derivative of t square is 2t. So this is basically 2at. So I'm going to put 2at. This is the derivative of at square, plus the derivative of bt is, when you apply the constant multiple rule, we keep the b as it is, and derivative of t is 1. So it's basically b times 1 is b, and then the derivative of constant c is 0. So yp prime, we get it as 2at plus b. Now let's find the second derivative of yp. That is, we find the derivative of yp prime, and this equals the derivative of 2at, which is 2a is a constant and derivative of t is 1. So it's basically 2a, plus we have the another constant b, so it becomes 0. So we found the expression for the yp prime and yp double prime. Now we substitute the yp prime and yp double prime into the original equation and solve for a, b, and c. So let's do that. I'm going to first rewrite the given differential equation in the yp form. So I'm going to replace this yp double prime by, I'm sorry, y double prime by yp double prime. This is yp double prime plus, we have 10y prime, so that can be replaced as yp prime plus 24y, it is replaced as yp, and on the right side we have 144t squared. Now I'm going to substitute for this yp double prime, yp prime, and yp, which we have found earlier. So yp double prime is 2a, so I put 2a plus 10 times of yp prime, which is 2at plus b. So I put 2at plus b plus 24 times of yp. Yp is at squared plus bt plus c. So I write at squared plus bt plus c, and this equals, on the right side we have 144 t squared. Now to solve for a, b, and c, we can simplify the left side expression, and we have to equate the coefficients. So first I'm going to consider the t square term. So this is the only t square term, so I write down this first, that is 24a t squared. Now I look out for the t term. So here we have this t term, that is 10 times of 2a is 20a. So I put 20a, and this is bt times 24 is 24bt. So I put only 24b, as I'm factoring out the t. So I write down this as t, and these are the only two terms. Now I look out for the constant term. So we have 2a here, so I put 2a plus this is 10 times of b is 10b. So I write 10b, and then this 24 times c is 24c. So this is also a constant, and this equals 144 t squared. So we can now equate the corresponding coefficients on both sides. So on the left side, the coefficient t square is 144. I'm sorry, that is on the right side. On the left side, we have 24a. So then we can say that 24a equals 144. And this implies we can solve for a by dividing both sides by 24. So we get 144 divided by 24, and this equals 6. So we say that the value of a equals 6. We found the value of a, which is 6. Now let's equate the coefficient of t. Here the coefficient of t is 20a plus 24b, and this equals, on the right side we don't have any t term, so we consider its coefficient as 0. So then we say that 20a plus 24b equals 0. Now I'm going to substitute this value of a into this equation so that we can determine the value of b. So it is 20 times a is 6 plus 24b, and this equals 0. So this implies 20 times 6 is 120, plus 24b, and this equals 0. So we get 24b equals negative 120. I subtract 120, and we can solve for b by dividing both sides by 24. So we get negative 120 divided by 24, and this equals negative 5. So we found the value of b equals negative 5. Now let's equate the coefficient of the, I'm sorry, we have to equate the constant terms. So these are the constant term, and on the right side we don't have any constant term. So we can set up this equation as 2a plus 10b plus 24c equals 0. So let me write down here, that is 2a plus 10b plus 24c. This is 10b plus 24c, and this equals 0. Since we already know the value of a equals 6 and b equal to negative 5, we can substitute into this equation. That is 2 times of a is 6 plus 10 times of b is negative 5 plus 24c equals 0. This is 12 minus 10 times 5 is 50 plus 24c equals 0. 12 minus 50 is negative 38 plus 24c. This equals 0. So when we solve for c, we get c equals negative 38. I'm sorry, it is positive 38, since we add 38 on both sides. So we get 38 over 24. And we can reduce this fraction to simple terms, which is 19 over 12, because we see that this is 19 times 2 and this is 24 is 12 times 2. We then cancel out the common terms, which reduces to 19 over 12. So we found the value of c equals 19 over 12. And since we have determined the values of a, b, and c, we can write down the particular solution, that is which is in the form of at squared plus bt plus c. So all that we do is we substitute into that equation. So first let me write down this particular equation, that is at squared plus bt plus c. So I write down yp equals, we replace a as 6. This is 6t squared plus b is negative 5. So I need to put negative 5 here. This is negative 5t plus c, which is 19 over 12. So we found the particular solution for the given differential equation. So this completes step 2. Now let's do step 3. So here we determine the general solution, that is y sub g. So we write down y sub g, that is the general solution, equals the complementary function plus the particular solution. So we just have to add the complementary function with the particular solution, which we found in step 1 and step 2. So I'm going to replace yc as this equation, that is c1 e raised to the power of negative 60 plus c2 e raised to the power of negative 4t plus, now I replace the expression for yp, that is 6t squared minus 5t plus 19 over 12. So this is the general solution of the given differential equation. And this completes step 3. Now let's do step 4, that is we have to find the unique solution y. So for this, I'm going to rewrite this general solution, that is yg, this equals y, and we will also have to determine the value of c1 and c2 using the initial condition. So first let me find the derivative of this one, because we have the initial condition y prime of 0. So first let me find its derivative. So this is y prime, and this equals, if we find the derivative of c1 e raised to the power of negative 60, using the chain rule, we will get c1 times negative 6 e raised to the power of negative 60. And similarly, when we find the derivative of e raised to the power of negative 40, we get c2 times negative 4e raised to the power of negative 4t, and then we find the derivative of the quadratic terms. That is, the derivative of 6t square is using the power rule. It is 12t minus the derivative of 5t is 5 times 1, which is 5, and the derivative constant is 0. So basically, we got this expression, or the y prime equals the expression on the right side. Now let's use the initial condition, that is, we are given y of 0 equals 19 over 12 and y prime of 0 is given as negative 5. First, let me use this y of 0, which equals 19 over 12, and for that I'm going to consider this y equation, and I'm going to substitute t equal to 0 into this equation. So then I will get y of 0, and this is given as 19 over 12. So I put 19 over 12, and this equals, I have to replace all the t's by 0. So therefore this becomes c1 e raised to the power of negative 6 times of 0 plus c2 e raised to the power of negative 4 times of 0 plus 6 times of 0 square minus 5 times of 0 plus 19 over 12. Now let's simplify this. So on the left side we have 19 over 12, and this equals, remember that e raised to the power of negative 0, which is equal to e raised to the power of 1 over positive 0, and 1 over positive 0, that is e power 0, is 1. So it's basically 1. So wherever we have e raised to the power of negative 0, we can write down that as 1. So this is c1 times 1 is c1. Similarly, for this expression, we have e raised to the power of negative 0, and the expression and the value of e raised to the power of negative 1, negative 0 is equal 1. So c times 1 is c2 times 1 is c2, and the next term 0 squared times 6 is 0, 0 times negative 5 is 0, and finally we have only 19 over 12. So now if we subtract 19 over 12 from both sides, we will get the equation, that is 0 equals c1 plus c2, or otherwise we can say that c1 equals negative of c2. Now let's substitute the second initial condition, that is y prime of 0 into the derivative function. So let me substitute t equal to 0 into the derivative equation. So therefore this becomes y prime of 0, and this is given as negative 5, and this equals, let's replace all the t's as 0. So therefore this equals negative 6c1. We know that e raised to the power of negative 0 is basically 1, so it is negative 6c1, and this is negative 4c2 plus this is 12 times of 0 is 0, and then we have negative 5. So let's evaluate this. On the left we have negative 5, and this equals negative 6c1, and this is negative 4c2. This is 12 times of 0 is 0, and we then have negative 5. So if we add 5 to both sides, we get 0 equals negative 6c1, negative 4c2. We now replace this c1 equals negative c2 into this equation to solve for one of the variables. So therefore we get 0 equals negative 6 times c1 is replaced as negative c2 minus 4c2. So this equals, we get 0 equals, this is positive 6c2 minus 4c2, and this implies 6c2 minus 4c2 is 2c2, but we get c2 equals 0 by 2, and this equals 0. So c2 equals 0, and this means if you plug it into c1, c1 equals negative of 0, or otherwise it is still 0. So c1 equals 0, and c2 equals 0. And so we can write down the final solution of this initial value problem, that is y equals c1 e raised to the power of negative 60. So I'm going to replace c1 equals 0. So this will be 0 times e raised to the power of negative 60 plus c2, that is 0 times of e raised to the power of negative 60 plus 6t square minus 5t plus 19 over 12. So it's basically the sum of the complementary function and the particular solution which we found in steps 1 and step 2. It's just that we have to determine the values of C1 and C2 and substitute into the final solution. So we see that this becomes 0 and this is also 0. So therefore, we see that the final solution of this initial value problem equals y equals 6t square minus 5t plus 19 over 12. This is the final solution. This is t squared. Let me write down a little bit clearly. This is 6t squared.